Hi everyone, Mrs. Venti here. Today's video is all about exponents. This video is from the Mind Action Series Grade 9, Exercise 1 on page 67. Before we get started, you need to know all the rules of exponents. So the rules of exponents all have to do with having the same base, or most of them do. The multiplication rule says that if you have two numbers with the same base and different exponents, you add the exponents. The division rule says if you have two numbers, same base, different exponents, you subtract the exponents. The power rule says that if you have a number to a power and you raise it to a power, meaning that there's a bracket and exponent on the outside, you multiply the two exponents. The product rule says that if you have two numbers in brackets, both of them raised to a power, it is equal to the first number to a power and the second number to a power. Similarly, the fraction rule says if you have a fraction in brackets to the power, it's the numerator to that power and the denominator to that power. The zero rule says that any number to the power of 0 is equal to 1. The negative exponent says that a number to a negative exponent is equal to that number going to the other side. Now, what do I mean by that? In the example, they give us a to the power of minus x, and they're saying that this is equal to 1 over a to the power of x. What you need to realize is that this a to the power of x is actually a fraction over 1. So this number here is a numerator, and it becomes a denominator without a negative sign, which means the opposite is also true. If you have a fraction and it says a to the power of minus x, it is actually where this goes and becomes a numerator, a to the power of x over 1 or not over 1. But the point is it's no longer a denominator. The last thing I want you to realize is that you have the fractional exponent, which is that if you have a square root sign or cube root sign, if you have a surd sign and you have a number on the inside, whatever is on the outside, it can be 2, it can be 3, 4, whatever it is, this will become the denominator in a fraction. So this technically is a to the power of 1. So that, if I write it as a fraction, is going to be a with an exponent of 1, which is the inside number, over 2, which is the outside number. Okay, let's try and use these rules in the exercises. So we're doing exercise 1 on page 67. Question number 1 says x to the power of 5 multiplied by x to the power of 5 multiplied by x to the power of 0. Now, the first thing that I notice is that I have the same base, x, x, x. Second thing that I notice is that I have multiplication. Now, the rule says that when I multiply, I add the exponents as long as I have the same base. So I'm going to keep the base of x, and then I am going to add. I'm going to say 5, which is this one, plus 5, which is that one. Now, I can add 0, or I can use the 0 rule, and I can say x to the power of 0 is equal to 1. So I can either just say that this here is 1, or instead what I'm going to do is I'm going to use the exponent rule and I'm going to add 0. So my answer to this question is going to be x to the power of 5 plus 5 is 10 plus 0 is 10, x to the power of 10. That is my final answer. Question number 2 has got the same thing, x to the power of 5 plus x to the power of 5 plus x to the power of 0. Now, again, same basis, that's fine. But what I do notice is that I have x to the power of 0. Now, when I'm adding, I normally add like terms. X to the power of 5 and x to the power of 5 are like terms. So what do I have? I have 2x to the power of 5. Whereas x to the power of 0 is not a like term, I cannot add it to that. But I know that x to the power of 0 is equal to 1, so I can just add it as 2x5 plus 1 as my final answer. Question 3. 2x3 times 3x3. Now, I've got different components. First thing I notice is I've got multiplication. So I've got times, and not only do I have times, I've got like terms or same basis. So if I use my same base rule, I'm going to say x 3 plus 3. But now what I didn't do anything about is the coefficients. So my coefficients are 2 and 3. Let's do it in a different color, 2 and 3. So I'm going to say 2 times 3 x3 plus 3. So 2 times 3 is equal to 6, and x3 plus 3 is equal to 6. And that's my final answer. Now question 4, again, it's the same thing, but instead of multiplying, I am adding. So again, what do I have? I have same base, x3, x3, and I'm adding. So if I have 2x3 plus 3x3, what I have is 5x3. That's my final answer. Notice the difference between multiplying and adding on this page. Okay, next question. Question 5. I am multiplying minus 4a4 times 5a5. So I start with my signs, and I'm going to say minus times plus is minus. Next, I'm going to look at my coefficients. So I'm going to say 4 times 5. And then finally, I'm going to look at my variables. My first variable is a. So I'm going to say a4 plus 5 because it's the same base, and I'm adding the exponents. When I simplify, I have minus 20 a to the power of 9. And that's my final answer. Question 6, we're going to do the same thing, starting with our signs. So I say plus times minus is going to give me minus. Then I'm going to say 3 times 5 m1 plus m2. Then I'm going to say n1 plus 5. And finally, p to the power of 0. P to the power of 0 is actually equal to 1. So I can write p0, but I'm just going to multiply it by 1 and eliminate it completely. Now let's simplify. Minus stays the same. 3 times 5 is 15. M to the power of 3. N to the power of 6. And that 1, if I multiply it in, it disappears. That is my final answer. Question 7. I am going to start with my signs. Minus times minus is plus. Then I'm going to say 2 times 3. Then I'm going to say x3 plus 2. And I'm adding because there's a multiplication sign. And then I've got y5 and y1. If I simplify the plus, I'm just not going to write. 2 times 3 is 6. x5 y6. Question 8. I am going to divide. Now, my signs are plus and plus, so plus and plus is plus. I'm not going to write anything there. Let's look. 6 divided by 2. I am going to say, let's divide both by 2. So 6 goes into 2 3 times, and 2 goes into 2 once. So I have 3 over 1. I'm just going to write 3 as a whole number. Okay? Now I'm going to do the p's. I've got p6. And because I'm dividing, the rule says that when you divide, you are going to subtract the exponents. So I'm dividing. I'm going to say p6 minus 2, which means that my final answer is going to be 3p4. That's my final answer to that question. Question 9. Okay, so now we've got different signs. I've got plus and I've got minus, which means my answer is going to be minus. Let's simplify. 4 and 8. Common factor is going to be 4. 4 goes into 4 one time. 4 goes into 8 2 times. So I've got a fraction 1 over 2. Let's do x's. I've got a dividing sign, which means I'm subtracting all my exponents. x5 minus 1. And then y4 minus 8. So let's simplify. This then becomes minus a half x4 y minus 4. Now if I combine this as a fraction, what I need you to remember is that the rule says if I have a negative exponent, which is what I have here, it means go to the other side. Right now, I have y minus 4 over 1. It is a numerator. To make this minus sign positive, I am going to move this to the other side and make it a denominator. So my answer is going to be minus in front of the whole fraction. I have a fraction line with 2 at the bottom and 1 at the top. My x4 stays at the top because it's positive. It is at home. I'd leave it where it is. Whereas my y4 must go home. It must go to the other side. So y4 is at the bottom as a denominator. And that, my dear friends, is my final answer for this question. Minus x4 over 2y4, or 1 over x4. 1x4. So that answers our question number 9. Let's look at question number 10. Question number 10, we start with our signs. So our signs are going to be minus and minus. 1, 2 is a plus sign. 6 divided by 3, our common factor is going to be 2. 2 goes into 6 3 times. 2 goes into 8 4 times. So I have a fraction of 3 over 4. Now I'm going to write my p's. It's going to be p3. Notice that I have a divide sign, so I'm subtracting. Minus 3. p3 minus 3. Then my q is going to be q5 minus 4. And my r is going to be r2 minus 5. Okay, let's simplify. So that then becomes equal to 3 over 4. P3 minus 3 is P0. Q, 5 minus 4 is 1. And R, 2 minus 5 is minus 3. Okay, so that's now simplifying my equations on the exponents. Now let's get rid of any negative exponents. My fraction is going to be 3 over 4, right? P0 gets eliminated because that is technically equal to 1, so I don't write it. My q goes on the top, q to the power of 1, and my r, because it's a negative exponent as a numerator, it becomes a positive exponent as a denominator. And that, my dear friends, is your final answer. 3q over 4r cubed. Next question, we are multiplying 3p squared q over 10p 3q4 times 5p 3q3 over 6p q squared. Right, so what do we want to do? We are multiplying. All right, first thing I notice is that all my signs are positive, so I'm going to ignore the signs because my answer is going to be positive. Now let's look at our coefficients. If I was multiplying, then I would just multiply the numbers, but I'm multiplying and dividing. So I want to see if I can cancel out top and bottom, right? I can cancel out 3 and 6 with a common factor. So 3 goes into 3 once, and 3 goes into 6 twice. So that simplifies. I can also cancel out 5 and 10, where 5 goes into 5 once, and 5 goes into 10 twice. So now I have 1/2 times 1/2. Awesome. That already simplifies things. So what do I have in terms of numerators and denominators? I'm just going to do the numbers alone and then my variables separately. So 1 times 1 is 1 and 2 times 2 is 4. I have a quarter. Next up, let's do the p's. So I'm going to say p2, that's that one. Times means I add, plus p3. Divide means I subtract, minus 3, and then because it's at the bottom, I'm still subtracting it, so minus 1. So 2 at the top, which are positive numbers, and 2 at the bottom, which are negative numbers. I'm adding the 2 at the top, I'm subtracting the 2 at the bottom. Now let's do our q's. Q is going to be q1 plus 3, that's 3, minus this 4, minus this 2. and that is our answer. Now let's simplify. I keep my quarter, p. Plus 3 minus 3 cancel out and they become 0. So I have 2 minus 1, which is going to be p1. And then q, 3 and 1 is 4. 4 minus 4 is 0. So those cancel out and make 0. I have q minus 2. Again, now if I write this as a fraction without any negative exponents, I am going to have 1 over 4. P goes on the top and q squared goes at the bottom. That is my final answer for question 11. Question 12. I have 2x squared in brackets raised to the power of 3. Now what this means is, again, my signs are all positive, so I'm going to ignore the signs. What do I have? I have this 2 raised to that 3, and I have this x squared raised to this 3. So the relationship there is multiplication. A power to a power means you multiply the exponents. Okay, since I've got that sorted out, I am going to expand. I'm going to say 2 to the power of 3 is 8 and x 5. That is my final answer for this question. Question 13, same thing, except now I've got a negative exponent. So what do I have? Technically, I have minus times minus, which is plus, okay, because I have 2 minuses. That's plus. Then I have 3 to the power of 2. I have x1 to the power of 2. So I am multiplying 1 times 2. And then I have y5 to the power of 2, 5 times 2. If I simplify this, I have plus 3 times 3 is 9, x squared, y 10. That's my final answer. Question 14. Now I have a monomial outside, and then I have a bracket to the power of 3, and I have digits inside. So let's keep this on the outside, and we are going to deal with our bracket. So what do I have? I have minus times minus times minus. I have 3 minuses. Okay, so overall this here is equal to minus. Then I have 2 to the power of 3. So let's put that in bracket. Okay, I have x cubed to the power of 3, that 3. Then I have y squared to the power of 3, that 3. So I'm multiplying them, and I put all of those together. So do I have 3 times, in my bracket I have minus 2 times 2 is 4, times 2 is 8. So 8, then I have x, 3 times 3 is 9, and I have y, 2 times 3 is 6. And I can close my bracket. So I'm done inside the bracket. In terms of Beat-Maths, what we've done now is we have dealt with the exponent. Now we are going to do the multiplication between each of these here. So we are going to say plus times minus is minus. 8 times 3 is 24. x9, y6. Done. That's your final answer. Question 15, we are subtracting. All right. So what is important here is we are going to go through the order of Beat-Maths. Inside my brackets, x, I've got nothing to do there. X cubed, I've got nothing to do there. So I'm going to start with exponents. So I'm going to keep everything the same, and minus 2 there. And what I'm going to do is exponents. So I'm going to say x1 times 3 is going to give me x3. I said 1 times 3. And this one is going to be x3 times 2 is going to give me x6. So now I've got x to the power of 3 minus 2, 3x to the power of 3 minus 2x to the power of 6. there is nothing that I can do here because these are not like terms. 3 and 6 are different. X is not equal to x to the power of 2. They are not like terms, which means I cannot add them. So x3 is not the same as x6, which means I cannot add them. Therefore, this here is my final answer. Next question. Question 16. B oddmas says deal inside the brackets first. So inside my brackets, I have a plus. Can I add those two? Yes, I can. So this is going to become, inside my brackets, I've got 2x5. And I keep my exponent on the outside over x5 times x5. Okay? Now that I have that done, I can say exponents. Okay? So I'm going to deal with this square over here. And I'm going to say I've got 2 squared, which is 4. x5 times 2 is x10. And that is going to be over x5, times x5. So the next step that I'm going to do is I'm going to deal with my denominator because my numerator is done. So my numerator is 4x10 over, and what I have at the bottom is x5 plus 5 because I'm multiplying with the same base. So that is actually x10. Do you agree with me? So the next step is I can cancel out like terms. X10 cancels out with x10, which means my answer is 4. That's my final answer. But I just want to show you something. If I was to use the rules of exponents, I could say x10 on the top minus, because I am dividing, x10 at the bottom, the green one, which gives me x0, which is equal to 1. So then I have 4 times 1, which is equal to 4. So both ways, my final answer is 4. Question 17. Again, we're going to do B oddmas. So inside the brackets, 3m cubed n, there's nothing I can do. Minus 2m and 3, there's nothing I can do. My second step is going to be exponents. So I'm going to deal with that 2 and that 3. So let's do that. My minus 4 stays on the outside. And inside my bracket, I have 3 cubed, 3 squared. 3 times 3 is 9. M, 3 times 2 is 6. And then N1 times 2 is 2. That is going to be my numerator over my denominator. Minus times minus times minus is minus. 2 times 2 is 4 times 2 is 8. M1 times 3 is 3. N 3 times 3 is 9. That is step 1. Then step 2 is going to be, let's deal with our like terms. So in terms of like terms, I have got, well, let's do signs first. Minus and minus. Minus and minus is plus. And then 4 and 8 simplify with 1 and 2. So I have a half, right? No. I need to multiply first. Hold on. All right, first we need to multiply this 4 in. So what are we going to do? We could simplify by dividing first. Actually, let's divide first. Because we have multiplication and division, we can do either or. Both of them work at the same time. So I can say 4 times 9, which is going to be 36, and then divided by 8. Or I can just say, okay, 4 and 8 simplify to 1 over 2. So I've got plus 1 over 2. And then on the numerator, I literally have 9m6n squared. And in the denominator, I have m3n9. And this 1 can fall away. Okay, so I have 9 over 2. So let's simplify this even further. I'm going to say 9 over 2 is my bracket. M6 minus 3, N2 minus 9. And that becomes 9 over 2, m3n minus 7, which then in the end becomes 9m cubed over 2n7 as the final answer. Okay, question 18. For question 18, we can't do anything inside the bracket, so let's start with the exponents. Let's deal with this 4 first. This is going to become a 2 times 4 is 8, b 1 times 4 is 4. Okay, multiplied by 6, a, b, 3, we keep that. And then at the bottom, let's work with this 2. We're going to say minus times minus is plus, 3 times 3 is 9, a, 5 times 2 is 10, b, 2 times 2 is 4. That's what we got. Next up, we are going to multiply and divide. So let's do it all in one go. I'm sure you'll notice now what I'm saying. So let's start with the 6. Because everything's plus, I'm not going to worry about that. So my 6, I have 6 divided by 9. Let's simplify. We can divide by 3. 3 goes into there twice. 3 goes into there 3 times. So I've got 2 over 3 as my coefficient. Now let's do a's. I'm going to say a8 plus 1, that's that 1, minus 10, that's that 10. And then I'm going to do my b's, b4 plus 3 minus 4, that one. Okay, let's simplify. 4 minus 4 cancels out, that makes 0, so I have b3. And then 8 plus 1 is 9. 9 minus 10 is minus 1. So what I have is, I have 2 over 3, and then I've got a minus 1. 9 minus 10 is minus 1. b3, and if I get rid of my negative exponents, I have 2b3 as a numerator and 3a as a denominator. That's my final answer. Question 19. Okay, let's have a look here. I've got to divide. Now, the first thing that you must notice, okay, I've got a fraction. So without any inadvertently, we know that this is actually a fraction over 1. What you need to know is when you have a division of a fraction, the divide becomes a multiply, and the fraction a over b becomes b over a. So you multiply by the inverse is how we pronounce it. We multiply by the inverse of what is given to us. So on the left hand side, we are going to keep 4c0a3. Then divide becomes times, and on the right hand side, our numerator, this one, goes to the bottom of the line, 2a3b squared, and our denominator goes to the top, minus a cubed b cubed squared. All right, now I can work with this. Let's start with, I want to get rid of this bracket with the exponent. So if I was to do that, I am going to do this right now. I would say I'm keeping the minus because it's outside the bracket. I'm going to say A, 3 times 2 is 6. B, 3 times 2 is 6. And that is what that numerator becomes. The denominator stays the same, 2a cubed b squared multiplied by 4c0a3. Now automatically you know that c to the power of 0 is 1. I can just remove it. Okay, so let's start with our coefficients. Let's say we're going to say 4 and 2 cancel out. Remember, this is over 1. So I can cancel across. I can say 2 goes into 2 one time. 2 goes into 4 2 times. So I'm left with 2 wholes. And then I'm going to deal with the A. So let's deal with this A. I'm going to say A 3, and because I'm multiplying, I am going to add plus 6, and then I'm dividing, so I'm going to subtract minus 3. I made a mistake, or I overlooked something, and that was the sign. The sign comes first, so plus times minus is minus. Then the 2, then the A's, and now let's do the B's. My B's are going to be B6 minus B2. Okay, so if we simplify, this becomes minus 2. 3 and 3 cancel out and become 0, so it's A6. And B6 minus 2 is B4. And that's my final answer for question 19. Question 20, everything to the power of 2. So this is simple. If I do this, I'm going to say my numerator is going to be 2 times 2 is 4. X, 2 times 2 is 4. Over y, 1 times 2 is 2. And that's my final answer. Question 21. Let's start with doing the exponent. So we're going to do this one first. And we are going to take the entire bracket and square it. So let's start with minus times minus is plus. 6 squared is 36. A times 1 times 2 is 2. B 2 times 2 is 4. Over A 3 times 2 is 6. B 1 times 2 is 2. So that is just multiplying everything by the exponent of 2. And on the right hand side I have A3 4, B over 4A, B3. Okay, my next step is I'm going to try to cancel and make smaller my coefficients. So I'm going to check on the top. I've got 36, at the bottom I've got 1 and 4. 36 and 4 are compatible. 4 goes into 4 one time, 4 goes into 36 9 times, and then 1 and 3, that's as simple as it gets. Those are prime numbers. Okay, so what do I have? I have 9 times 3, which is going to be 27 over 1. So 27 as a whole number. Then I've got A. So I've got A squared plus 4 minus 6 minus 1. And then I've got B4 plus 1 minus 2 minus 3. And that's everything. I've got A, B's, and my numbers. So if I simplify this, I've got 27. A, 4 plus 2 is 6. 6 and 6 is 0. So I've got A minus 1. Can I go ahead and write this as a denominator? Okay, let me write it fine, and then we'll change it. And then on my B's, I've got 4 plus 1 is 5, and 3 plus 2 is 5. So this all cancels out to be 0. Be 0. So if I simplify this, this ends up becoming 27 over A, because B to the power of 0 is actually equal to 1, so I don't write anything there, and A to the power of 1 becomes a denominator. That is the end of question 21. Okay, I'm going to stop there for this video since we're already over half an hour, and then I wish you all the best. I hope that you understand. If you have any questions, please shout out and let me know, and I'll see you for exercise 2. Please like and subscribe, and good luck. Thank you. Bye-bye.